Okay, now you need to find out the derivative of y is equal to sine of ax plus b upon cos of cx plus b. Okay, say sine of ax plus b is equal to 2 and cos of cx plus d is equal to b. Clear? So your u is equal to sine of ax plus b. Okay, so you need to find out the derivative for this. Okay, so what would be the derivative for this? Assuming this is equal to t, your ax plus b is equal to t. Okay, actually what you need to do is that you need to find out the derivative for this, that is uh, d of u by v. Okay, so putting the question rule, what you need to do is v into derivative of u minus u into derivative of v upon v square. This is the derivative of this term. So you need to find out first of all the derivative of u here. So for that, how will you do? You will just substitute ax plus b, say it's equal to t. So your u could be written as say sine of t, and t is nothing but ax plus b. So from here you will find out du by dt. From here you will find out dt by dx. Okay. So sine of t is equal to say cos of t. This is equal to a into 1 plus 0, because the derivative of x is 1, derivative of constant is 0. So dy by dx is equal to, sorry, dy by dx is equal to du by dt. Du by dx is equal to du by dt into dt by dx. So substituting the value of du by dt, which is equal to cos of t, and then substituting the value for dt by dx, which is equal to a. So it is a cos of t. Substituting the value for t, it is a into ax plus b. Similarly, you can also see the uh, your v is equal to cos of cx plus d. Okay, so assume cx plus d say is equal to s. So your v is equal to cos of s, and s is equal to cx plus d. Okay, so from here you can find out dv by ds. From here you can find out ds by dx. So your dv by dx would be equal to dv by ds into ds by dx. Clear? Now what is dv by ds equals to? Minus sine of s, because the derivative of cos x is minus sine of x. What is the derivative of this? That is c into derivative of x is 1 plus the derivative of d is 0. Okay. Remember that even in cx plus d I am putting a question rule. Okay. So what is the derivative of dcx? That is first function as it is into derivative of second function, which is 1, plus second function as it is into derivative of first function, which is 0. So this is equal to c. Okay, so from here you are getting this. So this is equal to c. Fine. So I am substituting the value of dv by ds, which is minus sine of s, and then substituting the value for ds by dx, which is c. So this is minus c into sine of cx plus d in place of x. This is cx plus d. Now remember that this is your derivative. Okay, so this is your derivative, which is v into du by dx minus u into dv by dx upon v square. That is, see, we said this, that your y is equal to v upon u. Okay, so if we need to find out dy by dx, we need to find out the quotient rule of this. Okay, sorry, u upon v. Sorry, u upon v. So this is denominator as it is into the derivative of numerator minus numerator as it is into derivative of denominator upon denominator square. Fine. So what is the value for v? Let's start substituting it. What is the value for v? The value for v is cos of cx plus d, cos cx plus d. What is the value for du by dx? This you have just found out, which is a into cos of ax plus b. Okay, that is a into cos of ax plus b. So guys, I've found it out. Minus u. What is the value for u? U is sine of ax plus b. So sine of ax plus b. What is the value for dv by dx? You have found out this, which is minus c into sine of cx plus d. Okay. Now this minus minus would get plus upon the value for v square, which is cos square cx plus d. So this is your dy by dx in this case.